Hello my friends and welcome back to the You Can Do TV channel. At Salzgitter Flachstahl GmbH, the hot rolling mill transforms massive steel slabs into coils up to 1.5 kilometers long. Stored across 15,000 square meters, up to 2,500 slabs are reheated in 4 furnaces to 1,250 degrees Celsius, consuming energy comparable to 200,000 households annually. The slabs are compressed in a powerful descaling press with 2,200 tons of force, reducing their width by 300 millimeters. In the roughing mill, twin 20 megawatts motors apply 5,500 tons of rolling force to reduce thickness from 250 millimeters to 45 millimeters. The finishing mill feature stands rated at 30 megawatts each, over 40,000 horsepower, delivering final strip thicknesses from 25 millimeters down to just 1.5 millimeters and widths up to 2,020 millimeters. The strip is rapidly cooled from 750 degrees Celsius to 50 degrees Celsius using 100 million cubic meters of water annually. Finally, the steel is coiled, up to 35 tons per coil, 1.5 kilometers in length, with annual output reaching 150,000 coils, or 3.8 million tons. At Saint-Just Desvern facility, the production of round brass bars begins with the precise melting of copper and zinc to form a high-quality alloy. The molten metal is cast into molds to create billets, which are then cooled and thoroughly inspected. These billets are reheated and hot-rolled through multiple passes to gradually reduce their diameter to the desired size. The bars are then straightened, surface treated. Throughout the process, strict quality controls ensure dimensional accuracy, surface finish, and mechanical properties. Each bar is cut to the customer's required length using precision saws and automated measuring systems. Finished bars are labeled, bundled, and prepared for delivery. Throughout every stage, rigorous quality controls monitor dimensional tolerances, surface finish, and mechanical properties. This modern, streamlined process enables the production of high-performance brass bars suitable for industrial, decorative, and electrical applications, maintaining reliability, precision. Genk KLR Metal operates a fully integrated aluminum recycling facility equipped with TRF5 tilting rotary furnaces and REVERBER5 tilting holding furnaces. These systems enable precise temperature control and alloy consistency during melting. The plant processes aluminum scraps such as dross, foil, and chips into high-quality T-ingots, billets, and deoxidizers. The production of parabolic leaf springs begins with heating high-strength spring steel strips in a controlled furnace, raising the material to the required forming temperature. Once sufficiently heated, the strips are transferred to tapering machines equipped with CNC control. These machines gradually reduce the thickness of the steel along its length, creating a parabolic profile that enhances flexibility and optimizes stress distribution. After the tapering process, the leaf undergoes precision hole punching to accommodate center bolts or clamps. High-tonnage punching presses are used to ensure clean, accurate holes without deforming the material. This streamlined step process ensures the production of reliable, high-performance leaf springs for commercial suspension systems. From forging and surface hardening to brazing and bending, every process is optimized through focused, clean, and precisely controlled heat, delivering consistency, energy savings, and high-quality results. Duolin offers high-efficiency induction heating systems tailored for industrial processes, including forging, surface hardening, brazing, and bending. These systems deliver rapid, localized heating with excellent temperature control, suitable for both mass production and precision applications. The fully automatic induction heating line for hexagonal bar ends and carbon steel round bars ensures uniform, deep heat penetration, ideal for forging operations. Automatic steel plate induction heating systems allow efficient flat material processing with minimal thermal distortion. In surface treatment, Duolin's CNC induction roller hardening machines and shaft surface hardening equipment provide consistent hardening depth, enhancing wear resistance and fatigue strength. These machines are fully programmable for varied geometries and hardness profiles. For joining applications, Duolin offers saw blade brazing and welding solutions using induction technology to produce clean, strong joints with reduced oxidation. Machine tool silver brazing systems ensure accurate bonding of cutting tools and inserts under controlled heat profiles. All systems integrate advanced control features such as temperature feedback, programmable logic control (PLC), and robotics compatibility. Duolin's technology improves cycle time, energy savings, and metallurgical quality, making it a trusted solution for automotive, tooling, and manufacturing industries. MMTC PAMP operates a world-class precious metal refinery and minting facility near New Delhi, designed in collaboration with Switzerland's MKS PAMP. The refinery processes doré from global mining partners, starting with secure unloading and treasury weighing under stringent surveillance. During the melting phase, representative samples are extracted and analyzed in a metallurgical lab equipped with fire assay, ICPOES, XRF, and spark spectrometry, following LBMA and ASTM standards. Impure gold is cast into anodes and refined via electrolytic electrolysis, depositing 99.99% pure gold sponge onto cathodes. This sponge is then washed, dried, and formed into grains or bars. A CNC-controlled stamping press ensures precision serial numbering, with weight captured by Mettler Toledo, scales directly into the inventory system. Silver, recovered from doré or gold refining, undergoes crystallization to achieve 99.99% purity. 3 RBI standard secure vaults house finished bullion. The minting section features advanced strip rolling, blanking, embossing, and polishing equipment. In-house die manufacturing ensures design consistency, including the patented lotus motif. Annual capacities include 100 MT of gold, 600 MT of silver, and 2.5 million minted pieces. MMTC PAMP maintains strict environmental compliance using Swiss-grade filtration and metal recovery systems, reinforcing its role in positioning India at the forefront of global bullion markets. The Foundry integrates X1 3D printing technology to modernize and enhance production. The X1 system enables high-precision mold production with complex geometries and minimal material waste. A semi-automated desanding station efficiently recycles unbonded sand with up to 95% reuse and mixing ratios of 80% regenerate. The system operates 24/7 with high reliability. Printed molds emerge nearly dust-free, requiring only light finishing. These are integrated into hybrid mold assemblies, combining conventionally made molds with 3D printed complex cores. The hybrid method streamlines production, reduces storage of physical models through CAD-based printing, and ensures dimensional accuracy with minimal post-processing. Coatings are applied to withstand casting temperatures. With in-house design and R&D, the foundry remains competitive, offering customers fully supported casting solutions from concept to completion. Witkowice Slavárny is a leading Czech foundry specializing in the production of high-quality steel castings. Using modern electric arc and induction furnaces, the plant ensures precise chemical composition control. The casting process includes pattern production, sand molding, core assembly, molten steel pouring, and controlled cooling. After solidification, castings undergo cleaning, heat treatment, and final machining. The foundry produces components for energy, transportation, and heavy industry sectors, including turbine housings and pressure-resistant parts. Every casting is rigorously tested using ultrasonic, radiographic, and mechanical methods in certified laboratories. With a focus on innovation and precision, Witkowice Slavárny combines advanced manufacturing technologies with decades of metallurgical expertise to meet the highest international standards in steel casting production. In the world of modern metal casting, where accuracy meets efficiency, the lost foam casting method stands out as a game changer, especially for complex steel components like tubes. The iron and steel lost foam casting production line for steel tube molding offers a fully customized solution for precision casting. The process begins with the creation of polystyrene foam patterns, accurately shaped to match the desired geometry of the final steel tubes. These foam patterns are then coated with a refractory ceramic slurry to provide a durable surface for molding. After drying, the coated patterns are placed in an oven room for controlled heating, ensuring structural integrity during the casting process. Patterns are carefully positioned inside a molding flask and surrounded by sand. The sand is compacted using a vibration table to eliminate voids and support the foam structure. Pouring basins, runners, and risers are glued onto the setup. Molten metal is smelted and then poured directly into the flask, replacing the foam with steel as it vaporizes. Once solidified, the flask is emptied and the castings are transferred to storage. Final processing includes shot blasting to remove residues, revealing clean, high-precision castings ready for further machining or assembly. Under intense heat and precision force, flat steel plates are transformed into strong, curved, dished ends, vital components for pressure vessels. In hot forming, the steel is heated to around 900 to 1000 degrees Celsius, increasing ductility for easier shaping. Hydraulic or spinning presses then mold the plate into toruspherical, ellipsoidal, or hemispherical forms. This thermal process ensures uniform thickness, reduces internal stress, and improves mechanical properties. Hot-form dished ends are ideal for high-pressure environments like tanks, boilers, and reactors. After forming, the edge is prepared for welding, ready to meet the strict demands of industrial performance and safety. The forging process for a valve body using the Anyang 18T open die forging hammer begins with heating the steel billet to forging temperature. The 20,500 kilograms ram delivers powerful blows with up to 630 kilojoules of energy to shape the metal precisely. The operator controls the deformation step by step, gradually forming the valve body geometry. An advanced absorber system is installed beneath the anvil to eliminate ground vibrations during operation. This high-capacity hammer ensures uniform grain flow and structural integrity, making the forged valve bodies ideal for demanding petroleum pipeline applications where strength, pressure resistance, and reliability are critical. At HD Wires, steel wire production begins with high-grade raw materials undergoing precision drawing, pickling, and annealing processes. The wire is then galvanized for superior corrosion resistance, ensuring long-term performance in adverse environments. Advanced machinery and BIS-certified laboratories conduct continuous quality control, including UTS and resistivity tests. Products like GI wire, spring steel, and binding wire are manufactured to exacting standards. Each stage, from raw input to finished coil, is engineered for strength, durability, and compliance with global and Make in India benchmarks. At Hasever Metals Advanced Facility in Kahraman Maras, over 50,000 stainless steel pots and ceramic or granite-coated cookware are produced daily. The process begins with high-quality stainless steel sheets, cut and deep drawn into pot shapes using high-tonnage hydraulic presses. Bases are reinforced with multi-layer induction systems using aluminum or copper cores for even heat distribution. Handles are manufactured in-house and attached using automated riveting machines, ensuring strength and safety. Each product undergoes CNC edge finishing, polishing, and quality control for precision and appearance. Surface treatments, including ceramic or granite coatings, are applied in clean room conditions. Products are rigorously tested in Hasever's own technological laboratories for durability, food safety, and thermal performance. The laser beam is computer-controlled and directed onto the surface of the product, removing a fine layer of material to create a high-contrast logo that resists heat, corrosion, and wear. Laser marking is applied after polishing and before final packaging, guaranteeing a professional finish. This method reinforces brand identity while meeting global standards for product labeling in export markets. SSAW, Spiral Submerged Arc Welded, pipe manufacturing involves a precise and highly controlled process. Production begins with raw material preparation, where steel coils are opened and shaped. The spiral forming process shapes the steel into pipe form, followed by internal and external welding using submerged arc welding (SAW) techniques. Welding alignment ensures structural integrity. The pipe is then rotated for continuous welding. After forming, the pipe ends are polished, followed by X-ray testing and hydrostatic pressure testing to ensure safety and durability. Surface treatments include FBE or 3LPE coating and internal lining production. Finished pipes are loaded and shipped. This advanced laser cutting machine is designed for precise cutting of metal plates and H-beam steel structures. It supports both suspended and flat surface cutting, making it versatile for various industrial applications. Using high-powered fiber laser technology, the system ensures clean edges, minimal heat distortion, and high-speed operation. H-beams can be processed with exceptional accuracy, allowing for intricate profiles and efficient material usage. The machine's CNC control enhances automation, enabling seamless integration into structural steel fabrication, shipbuilding, and heavy machinery production. It's ideal for high-volume, high-precision cutting tasks. Lightweight, strong, and aerodynamically critical, aircraft wing ribs demand absolute precision in every cut. These aluminum components form the internal skeleton of wings, requiring advanced machining for strength and performance. This particular wing rib, made from 6061 aluminum, measures 1,960 millimeters in length, 635 millimeters in width, and 70 millimeters in height. The process begins with high-speed front and back rough milling at 22,000 revolutions per minute, with a feed rate of 40,000 millimeters per minute and material removal rate up to 7,000 cc per minute using a D50_R3 cutter. Subsequent stages include intermediate back milling at 12,000 revolutions per minute, feed 6,000 millimeters per minute with EUD16R3 tooling, and finishing at 12,000 revolutions per minute, 3,000 millimeters per minute using AUD10_R5 tool for high surface quality. Final cutting is done at 8,000 revolutions per minute with D16R5. The complete operation ensures tight tolerances, superior finishes, and structural reliability, essential for flight-critical aerospace applications. At Voestalpine Gießerei Linz GmbH, a demanding machining task required drilling 4 220 mm diameter holes, each 1,500 mm deep, into a 26-ton tempered steel housing. The solution came from Hermann Bills, whose custom-designed tool featured a centering HSS drill with internal cooling, 6 inner HSS inserts, and 6 outer carbide inserts. The complete tool system included an SK60 holder and 125 mm diameter base shank for stability. The process involved drilling halfway from both sides, then switching to full HSS inserts with reduced cutting speed, enabling smooth breakthrough and stable, efficient deep hole drilling. At Servi's Rissa facility in Norway, hydraulic cylinders are engineered with advanced CNC machining, submerged arc welding, and Simulation X virtual testing. The production handles piston diameters up to 2,000 millimeters and stroke lengths up to 20 meters. Certified DNV welding ensures offshore compliance, while in-house testing includes pressure, function, and particle control. Integrated MPS ERP systems streamline operations, and sea-based heat pumps provide eco-efficient heating. Servi delivers precision-engineered, high-performance cylinders for demanding industrial applications. At TZ Schramberg, precision meets efficiency through advanced CNC milling with solid cams integrated cam solutions. The machining process focuses on high-performance cutting HPC strategies using state-of-the-art solid carbide end mills. These tools are specifically selected for roughing complex steel components, offering maximum material removal rates while maintaining dimensional accuracy and tool longevity. The operation begins with toolpath generation in SolidCam, where optimized trochoidal milling paths reduce cutting forces and thermal stress. On the CNC machine, HPC end mills operate at high spindle speeds and feed rates, achieving consistent chip evacuation and surface finish. Multi-axis setups are employed for complex geometries, minimizing repositioning and downtime. Clamping systems are rigid and vibration-damped, ensuring stability throughout the cutting cycle. Real-time process monitoring and adaptive feed control further improve performance and tool life. Days. This seamless integration of SolidCam software with high-speed milling tools enables TZ Schramberg to deliver high-tolerance metal parts for demanding industries such as aerospace, automotive, and medical, reinforcing its reputation for innovation and technical excellence in modern machining. At BKT Durin, the manufacturing of a Kegel-Radwell bevel gearshaft begins with CNC turning, a key step in achieving high-dimensional precision. The raw material, usually alloy steel like 42 CRMO4, is clamped onto a CNC lathe, where rough turning operations shape the basic shaft profile, including journals, shoulders, and mounting surfaces. Subsequent finishing passes with precision tools refine the geometry, ensuring tight tolerances and surface finishes below raw 0.8 micrometers. Key features such as bearing seats, centering bores, and chamfers are machined in a single setup using multi-axis control, reducing misalignment risks. Threading, grooving, and undercutting operations are also integrated during the CNC cycle. Live tooling supports additional functions like axial drilling or transverse milling, minimizing repositioning. Continuous measurement using in-machine probes and adaptive control systems ensures consistent quality throughout production. This CNC turning phase prepares the Kegel well for further operations like gear cutting, heat treatment, and grinding, ensuring it meets the strict demands of high-performance drive systems. Bruck GmbH produces high-quality gears using advanced gear cutting techniques. With 4 milling machines, they apply 2 main methods. In downcut hobbing, a rotating cutter machines the gear continuously, achieving precision grade 9 for gears up to 7 meters in diameter and module 45 teeth. In profile milling, each tooth gap is cut individually using carbide tools, allowing angled cuts up to plus or minus 30 degrees, ideal for parts like wind turbine gears. Internal gear cutting is also offered. The process is eco-friendly, using no oil coolant thanks to carbide inserts. Friction stir welding, FSW, enables strong, melt-free joints in aluminum, ideal for lightweight vehicle construction. A rotating tool forges materials along the joint line. At PNNL, weld speeds increased from under 1 to over 3 meters per minute, making FSW viable for high-volume automotive use. The Omega Press Brake Tool enables precise bending of complex parts with minimal setup. Its specialized geometry supports multi-stage bends, deep profiles, and tight radii with high repeatability. Ideal for stainless steel and precision sheet metal work, it simplifies intricate forming tasks efficiently and accurately. At Metal Design, true Italian craftsmanship meets modern metalworking technology to deliver high-quality, custom metal components. The process begins with precision cutting using high-performance cutting discs, capable of slicing through aluminum, steel, and other metals with speed and accuracy. Each cut is made to exact dimensions, forming the base for further shaping. Next comes the art of metal spinning, an advanced forming process where flat metal discs are rotated at high speed and pressed over mandrels to create symmetrical, cylindrical, or conical shapes. Skilled technicians guide the metal with precision tools, achieving smooth contours and uniform wall thicknesses. This process is ideal for creating parts such as lighting fixtures, decorative elements, and industrial components. Every piece reflects dedication to detail, durability, and aesthetics. The combination of traditional techniques and modern machinery ensures that each product not only meets technical specifications, but also embodies the elegance and quality of Italian manufacturing. From concept to completion, they delivers form, function, and craftsmanship. The REI-VAX-DCN-16M is a CNC wire bending machine designed for manual bending of rods with high flexibility and precision. Built to handle both prototyping and short production runs, it features user-friendly programming that allows up to 10 different bend types per part. Its modular design ensures quick tooling changes, minimizing downtime during setup. Two machine variants are available, one for wire diameters up to E 10 mm and another for rods up to E 16 mm, covering a broad range of forming applications. This makes it ideal for small-scale manufacturing, R&D, and custom part development where versatility and ease of use are critical. The CNC control offers repeatable accuracy, while manual operation allows real-time adjustments and fine-tuning. Its compact footprint and intuitive interface make the DCN-16M a practical solution for workshops requiring efficient and cost-effective wire bending without compromising precision. The NARGESAMC 200 tube and profile bending machine, distributed by KACHEMBO Mexico, is a highly robust and versatile machine designed for precise bending of a wide range of metal profiles. Built from welded and machined steel plate, not cast iron, it offers superior strength and durability in the two-drive roller category. Ideal for manufacturing flanges, railings, greenhouses, tables, chairs, doors, windows, and spiral stairs, it can form a wide variety of circular and curved shapes in square, round, U, T, angle, and flat bar profiles. The MC200 features two knurled, motor-driven lower rollers for maximum traction, along with hardened and ground steel shafts measuring 40 mm in diameter and 74 mm in usable length. The distance between the lower shafts is 286 mm, and the machine can bend round tubes up to 2.5 inches, 63.5 mm. Bending is adjusted through the upper shaft, allowing precise control without deforming large diameter profiles. It includes 9 standard rollers and washers, a millimeter scale on the upper shaft, and side corrector rollers for spiral and helical bending. The machine can operate in both horizontal and vertical positions on the same base. Powered by a 1.1 kilowatts, 1.5 HP motor, it runs at 8 RPM and can be connected to 234 hundredths of a volt 3-phase power. It is shipped fully assembled on a palletized base and supports optional accessories such as a hydraulic kit and NIMF-15 wooden packaging for export. The Olympia 80HF linear cage forming tube mill is a fully automatic, high-performance system designed for producing carbon steel and stainless steel tubes using advanced linear cage forming technology. The model RCF 30-90 is capable of processing tubes with an outer diameter ranging from 30 mm to 88.9 mm, a maximum wall thickness of 4 mm, and production speeds up to 130 meters per minute. This forming system gradually transforms flat strip into a round tube using a series of linear roll cages, reducing stress on the material and ensuring excellent roundness and dimensional accuracy. The HF welding unit uses high-frequency induction to join the edges, delivering a strong and precise longitudinal weld. Equipped with universal-driven sizing stands and a universal straightening unit, the mill enables rapid size changes without the need for tool replacement, increasing production flexibility, and minimizing downtime. The universal Turk's heads ensure accurate sizing and final calibration. With robust automation, real-time control systems, and precision engineering, the Olympia 80 linear cage forming tube mill provides an efficient and reliable solution for producing high-quality HF welded tubes for industrial and structural applications. Tektubi Recordi specializes in the manufacturing of welded and seamless butt weld fittings in sizes up to 60 inches diameter, across all wall thicknesses and materials. The company's production capabilities include cold forming of Ts, mission-critical fittings for nuclear applications, and seamless hot-forged mandrel elbows up to 56. The facility is equipped with high-capacity gas and induction mandrel bending machines, capable of producing elbows in large radius bends up to 120. With a maximum forming force of 1,800 tons and heating systems operating at 850 degrees Celsius for up to 11.5 tons per hour, Tektubi ensures consistent forming precision and material integrity. Cold-formed elbows in stainless steel and exotic alloys are produced up to 16 inches, along with seamless and welded bends for pipelines. Both hot induction and cold bending processes are applied on pipes up to 60 inches, ensuring flexibility and high mechanical performance. Each product undergoes stringent laboratory testing and inspection to meet global standards. The Tsubaki Holyoke plant specializes in high-precision roller chain production using advanced forming, stamping, and heat treatment technologies. Key components are cold-formed and heat-treated to achieve optimal hardness and fatigue strength. CNC-controlled equipment ensures consistent dimensional accuracy, while inline vision systems monitor quality in real time. The plant employs sintered bushings with patented lubrication grooves, enabling lube-free operation in the Lambda chain series. Chains undergo tensile wear and fatigue testing to validate performance. With automated assembly, precision coatings, and strict process control, Tsubaki delivers durable, high-performance chains tailored for demanding industrial power transmission applications. Amidst the echoing rhythm of modern foundries where sand, metal, and automation converge, the no-bake sand system by Dhanalakshmi Controls and Equipments stands as a symbol of precision and efficiency. More than just a production line, it is the beating heart of high-capacity casting operations, engineered for consistency, speed, and industrial excellence. The no-bake sand system by Dhanalakshmi Controls and Equipments is a fully integrated and automated molding line designed for precision casting operations. This advanced system streamlines every stage of mold preparation, handling, and metal pouring using robust mechanical systems and centralized PLC SCADA control. The process begins with a fast loop system, enabling continuous circulation of mold boxes through all workstations. Patterns are mounted and processed at the rollover stripping system, where molds are inverted, stripped cleanly from the pattern, and transferred automatically. The empty pattern return mechanism ensures rapid pattern recirculation, optimizing the cycle time. Molds enter the primary oven for initial sand curing, followed by the coating area, where refractory coatings are applied to enhance surface finish and resist thermal shock. They then pass through a secondary oven for final curing before moving to the core setting and closing area. Here, mold handling manipulators assist in precise core placement and secure mold closure. The closed molds are pushed via trolleys into the pouring and cooling system, where molten metal is introduced and allowed to cool uniformly along a controlled cooling line. Once cooled, molds proceed to the knockout station, where castings are separated from the sand. Mold pushers move flasks downstream for further processing. Environmental control is ensured by a high-efficiency dust collector system, while the entire line operates under a central PLC control panel with an intuitive SCADA system for real-time monitoring, diagnostics, and data tracking. This highly automated no-bake system maximizes casting accuracy, reduces manpower, minimizes waste, and supports continuous, high-output production for medium and large-scale foundries. The Chester Surface Water Drainage Tunnel project demonstrates a technically advanced approach to urban infrastructure development, focusing on the installation of one of 7 tunnel shafts essential for the new stormwater drainage system beneath Chester City Center. This construction phase, documented from May to August 2021, began at the Grosvenor Roundabout, where extensive preparatory works took place to create a deep vertical shaft using traditional excavation and shoring methods. Once the shaft reached the designated depth, it was reinforced with concrete lining segments to maintain long-term structural integrity and safety for the tunneling phase. Next, the pipe jacking equipment was installed at the base of the shaft. This system included a robust hydraulic jacking rig mounted against a specially constructed thrust block. This thrust block serves as a reaction frame, transferring jacking forces into the surrounding soil as each concrete pipe section is pushed forward. Following this, the tunnel boring machine TBM was carefully lowered into the shaft using a crane. The TBM, designed for small diameter tunnels in urban settings, was aligned precisely and activated. As the TBM excavated the tunnel forward, precast concrete pipe sections were lowered into the shaft and sequentially jacked into place behind the machine. The process of excavation and pipe installation was repeated in cycles to gradually extend the tunnel toward the next shaft location, maintaining alignment and depth throughout. This method ensured minimal surface disruption and precise underground progress. The manufacturing of offshore wind turbine foundations involves forming steel plates up to 150 millimeters thick into circular sections, followed by double submerged arc welding (DSAW) for strong, uniform inner and outer welds. Pipe segments are joined using the multi-section pipe fabrication process. The transition piece includes the barrel, top platform for turbine attachment, deck plate to connect structural legs, and supporting girders. The structure's legs are reinforced with X-braces. Lower and upper jacket assemblies support the full structure, culminating in a 94-meter, 2,200-ton foundation. Special coatings are applied for marine corrosion protection before dockside shipment. In one of the most significant heavy lifting developments in Australia's construction and industrial sector, Turbine Heavy Lift and Shift undertook the full assembly of the Terex Demag CC8800-1 crawler crane, the largest of its kind operating in the country. With a maximum lifting capacity of 1,600 tons and modular adaptability for superlift and twin-boom configurations, the CC8800-1 stands as a flagship machine in Australia's heavy lifting fleet. This crane is engineered to perform in extreme environments and is now deployed to support high-value infrastructure, oil and gas, and energy projects across the nation. The assembly process was executed in several stages, beginning with the central carbody and slew ring. The central carbody forms the heart of the crane's rotating structure and houses the massive slew ring, a high-precision bearing allowing 360 degrees rotation under extreme load. The slew ring alone weighs over 10 tons and was lifted using a secondary crane, before being bolted into position with precision torque tools. Alignment checks were performed using laser measurement devices to ensure flatness and concentricity, crucial for smooth rotational performance under load. Following the slew ring installation, attention turned to the crossbeams, which span laterally between the crawler track frames. These steel-reinforced structures provide the main support for the crane's undercarriage and are designed to absorb and distribute high torsional forces during lifting operations. The crossbeams were lifted into place and secured using high-strength pins and locking mechanisms. Hydraulic jacks were employed to adjust beam elevation during positioning, ensuring millimeter-accurate alignment. With the foundational base established, the next step was the installation of the crawler tracks. Each crawler assembly, measuring over 10 meters in length and weighing more than 60 tons, was delivered on multi-axle trailers and maneuvered into position using SPMT's self-propelled modular transporters. The tracks were then hydraulically jacked and pinned onto the car body, completing the crane's lower structure. These robust crawler tracks provide both the stability and mobility required to support operations over uneven terrain. Once the base structure was complete, crews moved on to the attachments, including walkways, power packs, counterweight tray systems, and cable carriers. These were systematically installed and integrated with the main control system. The Superlift counterweight tray, an essential component for balancing large loads, was assembled and loaded with up to 640 tons of steel plates. Counterweights were lifted using smaller auxiliary cranes and guided into place using remote-controlled hydraulic jacks. Commissioning followed with detailed electrical and hydraulic integration, control system testing, and safety protocol checks. The crane's intelligent IC1 Plus control system was programmed to adapt to real-time lifting parameters, ensuring maximum capacity usage without compromising stability. All lifting components, including the hook block, wire rope system, and load cells, were calibrated to meet manufacturer and industry standards. The entire CC8800-1 assembly project required over 3 weeks of coordinated logistics, heavy transport operations, skilled rigging, and engineering oversight. Now fully operational, the crane sets a new standard in Australia's heavy lifting sector, capable of tackling the country's most demanding structural and industrial lifting challenges. The Rolls-Royce Trent XWB-97 is the most powerful engine of the Trent series, delivering 97,000 pounds of thrust. Designed for the Airbus A351,000, it features advanced materials, lean burn combustion, and fatigue control. First tested in July 2014, it offers high efficiency, low emissions, and proven reliability for long-range operations. The major overhaul of the steam turbine at Tampieri Energy by Depreto Industries centered on restoring performance, ensuring mechanical integrity, and integrating system upgrades. The turbine, rated for 20 megawatts electrical output with 30 T-hour steam extraction capacity, plays a dual role in cogeneration, power generation, and steam supply for seed heating and oil processing. Key technical operations included the complete disassembly of the turbine casing and rotor removal. The rotor underwent micro-shot blasting, followed by non-destructive testing, NDT, including magnetic particle and ultrasonic inspection. Dimensional controls were carried out to detect wear, distortion, or imbalance. Any faults were rectified through welding, machining, or component replacement. A significant upgrade was the replacement of the original static seals with floating ring seals, which reduce leakage, improve sealing efficiency, and allow better control over axial clearances. This modification enhances thermal stability and performance consistency. Rotor balancing was performed at high speed to meet ISO vibration tolerance. Alignment of rotor and casing was rechecked post-assembly using laser measurement systems. The turbine was returned to full operational state, achieving design output while improving efficiency and reliability. The overhaul required close coordination between field technicians, workshop teams, and engineering staff, ensuring readiness for unexpected findings. The result was a fully restored turbine meeting operational and safety specifications, ready for continuous industrial operation. ZF in Friedrichshafen, where Andreas H. builds truck transmissions used by nearly all major manufacturers, has transformed physically demanding work into an ergonomic, modern process. Thanks to the M3 project, focused on worker-oriented assembly, lifting and noise exposure are things of the past. Automated systems, rotating workstations, and smart carts support an aging workforce while boosting efficiency and quality. This 3,000 kilowatts, 6-pole slip ring motor undergoes a startup test, accelerating from 0 to 993 revolutions per minute in 90 seconds. Operating at 10,500 volts with a shaft height of 630 millimeters and weighing 13.5 tons, it's ideal for cement mills, compressors, and fans requiring high starting torque. The H-beam bending machine is designed to curve structural steel beams with high precision. Using synchronized hydraulic rollers, the machine applies uniform force to gradually bend the H-beam into desired arcs or radii without distortion. It is widely used in bridge construction, shipbuilding, and steel structure fabrication. The Lysholm screw compressor delivers high efficiency through its twin-screw, positive displacement design. Known for smooth, continuous airflow and high boost at low RPMs, it's ideal for automotive and industrial use. Its compact build, reliability, and power density make it a favorite for performance diesel and supercharging applications. The BOLDRINI Ribo Series flanging machine is a high-performance solution engineered for the efficient production of dished heads and cones, meeting global standards for precision and productivity. Designed with advanced forming technology, it guarantees superior surface quality, tight dimensional tolerances, and reduced production costs. With exceptional machine versatility, the Ribo series handles cold forming of plates from 2 mm up to 80 mm and hot forming up to 200 mm thick. The machine is capable of processing heads and cones in diameters up to 8,000 mm, including ASME 2:1 elliptical heads. This system supports the shaping of a wide variety of geometries, such as torospherical, hemispherical, and elliptical heads, while maintaining smooth, uniform contours. Its programmable control system ensures repeatability and consistency in each cycle, making it ideal for serial production. The Ribo series is optimized for high efficiency, offering fast cycle times, minimal operator intervention, and adaptability for both light and heavy-duty components. From pressure vessels to storage tanks, Boldrini delivers unmatched forming reliability, supporting industries such as energy, chemical processing, and petrochemicals with world-class flanging capabilities.